welcome to
the FameLab
UK final! Hello everyone and welcome to Cheltenham Science Festival and the 2021 FameLab UK final. Yes, we have a great night of brilliantly engaging science presentations lined up for you. Of course, it is my absolute pleasure to be back hosting FameLab again. My name is Greg Foote. I'm a science presenter and producer making content on TV and radio and podcasts and YouTube, and I am so looking forward to this evening. And if you're watching this, I expect you know what FameLab is, but if you do not, here's a quick reminder. FameLab is the leading science communication competition and training program in the world. Each year, thousands of researchers from across the globe receive training and then compete in heats. FameLab was created by Cheltenham Science Festival and is delivered globally in partnership with the British Council, making science accessible for all. FameLabbers have 3 minutes to capture their audience. 3 judges judge them on the 3 C's of FameLab: content, clarity, and charisma. And you, the audience, vote for your favourite 2. Each country crowns their national champion, and those national champions come together to compete for the title of FameLab International Champion. FameLab participants have gone on to present TV shows, give TED Talks, publish books, and so much more. FameLab is all about giving skills, confidence, and opportunities to scientists, engineers, and mathematicians to communicate their current research with the people that it impacts. This is FameLab's 15th and final year in partnership with the British Council, so watch this space for what is happening next, and also we've got something very special for you later to celebrate. However, we've got a UK final to run first, yeah? Through various heats and regional finals, we have narrowed down the competition from 200 entrants to 8 finalists. There they are, 8 of the UK's most charismatic and chatty scientists and engineers who tonight will be fighting it out for the title of FameLab UK Champion. Each finalist is going to have 3 minutes to share their science in an engaging and entertaining way. But here's the thing, no slides or visuals are allowed. They can use props, and I'm sure we are going to see some brilliant props tonight, as always, but it's just them talking to us through their camera about their science for 3 minutes. Now, we will be timing, there will be a buzzer, but we are okay with them finishing their sentence or their thought when the buzzer goes off, okay? Cool. Right. Each finalist's talks will be watched by 3 brilliant judges who will then each have the opportunity to ask them a follow-up question. And it's the judges that then have the arduous job of deciding who is going to be the runner-up and who is going to be crowned the FameLab UK 2021 champion. That person will walk away with £2,000 to go towards advancing their science communication interests, and they're going to represent the UK in the FameLab International Final, which is happening later this year. The judges will also name a runner-up, and the runner-up will bag themselves £1,000 to put towards something science communicatory. And there is an audience vote. Yes, now, you get to choose who to crown the FameLab UK audience favourite. They're going to get £1,000 and they're going to know that they were your champion. That person can be the same person as the judge's champion or the judge's runner-up. The decisions are totally independent of each other. But here is the thing. We are not live right now. I mean, obviously we are right now as we record this, but when you are watching, we are not live. Okay, this is a pre-record. because as we know, the tech gremlins like to attack at the most inconvenient moments, right? And we don't want that happening in the middle of a presentation competition. So you don't want your Wi-Fi dropping out or your camera falling over. So to be as fair as possible, we've pre-recorded this. We are recording it just like if we were on stage, right? The finalists are with me now, the judges are with me now. If their Wi-Fi does drop out, or if the judges message and say, I couldn't hear them or I couldn't see them for that bit of their talk, then they are allowed to restart. The beauty of doing a pre-record is that you don't need to see all that faff happening, right? Plus, you're going to get to watch higher quality versions of their talks because it's not going to just be through the Zoom camera. We're getting everyone to film it with another camera or their phone, so you'll get to see that. You are going to get more pixels for your penny than if you would if this was just all over Zoom or Science Help Us Teams. The judges are then going to deliberate after the final presentation. They're going to make up their decisions about runner-up and champion. The beauty of pre-recording is that we can chop that bit out as well. But that is when you are going to have your time to vote for the audience favourites. And while you do that, we're going to have a special video for you featuring some brilliant people looking back at FameLab history. Details on where to go for that audience favourite vote are on the screen now. But voting will not open until after all the finalists have spoken. Blimey, right, that's enough admin from me, I think you'll agree. Let me introduce you to our illustrious judges who are going to be grilling, and by that, of course, I mean chucking very friendly questions at our finalists. They are the people that hold the power to crown the champion, and I'm going to let them introduce themselves. Let's start with Dr. Becky Smethurst.
Thanks, Greg. Yeah, my name's Dr. Becky Smethurst. I'm an astrophysicist at Christ Church at the University of Oxford, and I study supermassive black holes and how they affect their galaxies. I also have a YouTube channel called Dr. Becky that's I'm really enjoying making content for every week, space news and fun space mysteries and stuff like that as well. And I was also a finalist in FameLab in 2014.
Brilliant, amazing. And yeah, do go check out Dr. Becky YouTube channel. It's brilliant. Thank you very much, Becky, for being with us. Next up then on the judges panel is Dr. Jaideep Gupta.
Hi Greg, I'm Dr. Jaideep Gupta. I'm a fellow of the Institute of Development Studies at the University of Sussex, and I research the science of cities. Now we all might think we know what cities are, but they're really complex systems that go beyond the engineering of the pipes and wires and roads and buildings. They're also the public parks, the spaces, the museums, markets, even the protests that happen within them. So a huge part of what I do involves bringing together engineers and material scientists and geospatial scientists with social scientists like myself, artists and planners and designers, and of course making the science of cities real for everyday citizens like you and I involves listening to them and also being able to tell a really good science story. So I'm really excited to hear all of your stories today.
Thanks, Jaideep. And we had such a great conversation last year, actually, as part of Cheltenham Science Festival. So thanks for that. That was so interesting. Right, the final wheel of the judges' tricycle is the one and only Robin Ince. Hey, Robin.
Hello, how lovely to be that final wheel on that quirky, but I think this is the one which has possibly got the puncher in it. I'm Robin Ince. I do, I've done about 150 episodes on Radio 4 with Brian Cox of a show called The Infinite Monkey Cage, and I've written a few books. I'm a Joke and So Are You, which is kind of about dealing with our minds, and another one called The Importance of Being Interested. And so that's what I'm very lucky. I get to meet lots of scientists. I have no particular great knowledge myself in anything whatsoever, which is why I love doing FameLab, because I'm just always enlightened by new ideas. I do a thing every Sunday with my friend Helen Chersky of a live science Q&A, and what I think is so delightful is to see the hunger that people have to know so many things about the universe, whether they're 6 years old or sometimes we get 97-year-olds asking questions.
97-year-olds on Zoom. Brilliant. Right, let's get into this then. Judges, what are you looking for in tonight's presentations? Spoiler alert, it's going to be the classic FameLab Triple C that we heard in the video earlier. But let's see which judge is focusing on which. Becky, over to you first.
So I'm going to be focusing today on content specifically. So first of all, obviously I have to be scientifically accurate, but also, you know, you could probably give a lecture series on all of the topics that the contestants have chosen tonight, but they've got 3 minutes. So I'm really intrigued to see, like, which bits did they choose to include in their presentation, what narrative did they choose to actually present that as well, the story, and also if it's presented at sort of the right level for, you know, someone who's never come across that topic either. So I'm really excited to see what they do with everything that they've picked tonight to talk about.
Brilliant, nice one. Jaideep, what are you focusing on?
Greg, I'm going to be looking for clarity in your presentations. So this means beyond being just understood, I want to see whether you put your subject into a context, right? Let us know whether this is a well-researched area, is it a very new controversial area, or is it a new exciting piece of research you're doing? So it's clarity that I'll be after today.
Brilliant, thanks very much. And Robin, I'm going to guess.
This one feels so unfair. This one is charisma, but it's such an interesting thing where there are brilliant scientific minds who are not necessarily great at giving their ideas to the public. Peter Higgs would be a great example. Peter Higgs won the Nobel Prize. What incredible importance of all his work. He was never a great lecturer, but then we have people, I would say, like Alice Roberts and Brian Cox, and people who have that ability to excite, create that bridge between an audience who might know nothing about science and to be drawn in. And it's a very difficult thing, you know. It's and when you see it mastered, when you see how someone is able to expose their passion for a subject, and people can see that in their eyes and in their presentation. So I will be looking for that. So it's like a Simon Cowell figure, really, which is rather unpleasant.
Do you have your trousers pulled up uncomfortably high?
Well, because we're doing this by Zoom, I love the fact you've presumed I'm wearing trousers.
Lovely, there's an image for us all. All right, enough from us. Let's crack on then. Tonight's order was chosen by random. And first up is John, a lecturer at the University of Bristol. John's area of research interest is antibiotic resistance. But outside of the lab, he's a bit of a pool pro. He's an ex-international pool player, no less, but recently he's come out of rugby retirement, so he's swapped the cue ball for a rugby ball. 3 minutes are on the clock. John, it's over to you.
Chemotherapy, major surgeries, medical procedures that rely on antibiotics to protect us from infection, all under continuous threat. By a silent pandemic 80 years in the making, antibiotic resistance. Antibiotics treat infections by attacking the bacteria that cause them. Resistance simply means that the bacteria avoid being harmed by those antibiotics. This is a plasmid. It's a circular piece of DNA that carries genes, instructions for the bacteria to behave in a certain way or make certain things. This would make the bacteria pink and fluffy. The balding Welshman gene, well, I've got that one. And then genes that make the bacteria resistant to antibiotics. Now, plasmids are important because with DNA in this form, bacteria can share DNA from cell to cell. Now, how do they do this? They firstly make a copy, and then they pass it through a tube called a pilus, injecting it in to a neighbouring cell. Basically, it's bacterial sex. And bacteria, they are horny little buggers. They do this all the time. All of them. I don't want to use the term bacterial orgy, but it is basically a bacterial orgy. Now, inheriting plasmids in this way, sharing plasmids in this way means the bacteria inherit the information within. So, for instance, traits like antibiotic resistance can spread really quickly through bacterial populations, which is bad for us, but it's good for the bacteria. This is a major advantage, protecting them against attack by antibiotics. But if these are so great, why don't all bacteria carry them? Well, plasmids are big, heavy things. They take up a lot of energy, make the cells slow and less fit. It's almost like carrying a really big, heavy rucksack around all day. Great if I'm going camping for the weekend. Not so great presenting at FameLab. So it becomes a choice. Does the bacteria carry this heavy burden for the certain circumstances where it may be protected under attack by antibiotics? Or does it ditch the plasmid, take its chances as a fitter, more energetic cell, albeit without that protection? It's these decisions that we are currently trying to understand in the context of how antibiotic resistance spreads. Because sadly for us, more and more bacteria are choosing the rucksack. Thank you.
John, come on back. John, it's judges' question time. And also, for any of you watching who had Bacterial Orgy on your FameLab UK final bingo card, John's just ticked that. Right, judges, over to your questions. Jaideep is going to kick us off.
Thanks, Greg and John. Wow, what a wonderful way to kick us off. Everything from that initial balloon pop that had me jump up in my seat to the bacterial orgy. John, I wanted to ask you what your research means for everyday lives. So how should we be changing our lives? Is this research changing how people are treating antimicrobial resistance, how they're understanding them, and are they changing their lives in any particular way?
It's really changing the way we understand how antibiotic resistance spreads. So what we can do is design strategies, more accurate strategies to stop that. And what it's also doing is influencing how we perceive developing new drugs to combat antibiotic resistance. From a general public point of view, the message is always the same in regards to responsible antibiotic stewardship, completing your course, washing your hands, etc., etc.
Great stuff. Thank you both. Who would like to go next? Becky is waving the pencil in the air. Becky, over to you.
Great, thank you, John. I'm so intrigued by the science behind this, and I'm wondering whether you talked about how the bacteria almost has to make this choice about whether to take on this antibiotic resistance part of its structure. Is there any chance that we could engineer that to make the choice for the bacteria in a way of combating this?
Yes, to an extent. So we can look at what plasmids, for instance, are the primary carriers of antibiotic resistance, and look at what traits they convey to the bacteria. Yes, but primarily it is designing accurate intervention strategies and taking this science into consideration when we interpret very early data in preclinical drug development. So a bacteria with resistance against a particular drug may not necessarily be a clinical threat.
Thanks very much. Robin, final question.
John, well done. That was great. I just wondered, because I like all the craft that you've used there. Love it. And I wondered, was there, as you were doing all these things, and is there in your mind something you think, one day when I've got the huge budget and I'm at the O2, this is what I'm going to build to talk about antibiotic resistance? Have you got that kind of the dream prop?
Yeah, probably a giant inflatable bacteria that we can explode rather than a white balloon and a Sharpie.
So that's how it would start then. So you imagine you would see this bacteria roll on. You're not even on stage. A vast explosion. I like that. Excellent.
It would descend from the back over the audience, perhaps down to me on stage.
Brilliant. But much like The Prisoner, which you're too young to know about, but from 1967, that would work.
Or I'd channel my inner rock god and ride the bacteria down over the audience to stage.
Excellent. I will pass these all on to Brian Cox, who will of course immediately steal them for his next tour.
Yeah, John, I was imagining you inside it like a Zorb. You like running the bacteria in. Okay, fantastic. John, thank you so much. We are off. Let's keep this momentum going. Let's get into our second finalist. Our second finalist is Dagmar, a PhD student at the University of St Andrews. Dagmar's research looks at archerfish, and outside of the laboratory, she enjoys bird watching, rock pooling, and is really getting into photography. You've got 3 minutes starting when you do. Over to you.
Picture the face of the last person you saw before watching this video. It might be your partner, child, roommate, pizza delivery driver. It doesn't matter. Picture their face. Got it? Good. And now picture the faces of every single person you have ever seen in your entire life. I bet you can't. I mean, there's no way your brain would be able to remember all those details, right? You might be surprised to hear then that the human brain can actually recognize about 5,000 different faces. We use quite a lot of our big brains to put together the different parts of a person's face, like the eyes, mouth, and nose, into an individual. So would you believe me if I told you that there's a creature with a brain the size of a grain of rice that can recognize human faces too? I study archerfish, tropical fish that spit jets of water at insects above the water surface. Cool, right? But archerfish are much more than just their hunting tactics. They're actually capable of recognizing over 40 different human faces, which we know because they spit at the faces they associate with food, which means I get spat at a lot. And they do all of this without relying on cues like color, brightness, or head shape. Now sure, 40 is no 5,000, but why would a fish need to recognize over 40 different humans? Archerfish seem to be very good at something that they have no real reason to be very good at. And that's not even all. Archerfish can also take faces that they've learned in 2D and recognize them even when those faces are rotated up to 90 degrees, which suggests that they aren't simply memorizing the images they're shown. Instead, they're generalizing those images across multiple unlearned angles. But I'm sure you're thinking, yeah, sure, Dagmar, that's cool, but why does it matter? Well, we've long thought that humans' ability to recognize each other is something we're born with, and that it comes from a part of the brain called the neocortex, which is unique to mammals. But if fish who don't have a neocortex can also recognize different humans, it suggests that this ability developed much, much earlier in our evolutionary history than we currently think. In fact, archerfish are so good at recognizing different humans because they're good at pattern recognition. And it's likely that our own ability to recognize each other comes from that exact same place. We humans love to brag about how smart we are, how no creature can even come close to our incredible intelligence and cognitive skills. But archerfish are showing us that a lot of these so-called human abilities may not be as unique as we like to think they are. It's time we start giving some credit where it's due and realize just how many of our skills we might owe to our fishy ancestors.
Dagmar, thank you so much. That was fascinating. I'm just picturing you getting fired in the face by these archerfish that you study. Okay, over to the judges then for questions. Becky is going to start us off this time.
Yeah, thank you, Dagmar. That was so good. I've never heard of archerfish, if I'm quite honest. So that was so entertaining and so informative. I'm wondering though, how do we actually know this? I kind of feel like, as a human, maybe I do see 5,000 people in my day-to-day life eventually, but an archerfish, why 40? Is it because they only ever see 40 around a lab? Are you literally just showing them mug shots? How are you actually getting at them recognizing a face in this way?
So this experiment where they figured out that these fish could recognize different human faces was actually done using images of faces. So they used about 45 images, and they taught the fish that one of those faces, if they spat at it, they would get food. But the other 44, they wouldn't. And then they would show them a random face, and they would only spit at the face that they'd been taught to associate with food. And we see this in the lab as well. So I feed my fish Monday through Friday, but if I'm away and someone else has to feed them, they won't spit because they don't associate that person with food. And it was even to the point where, we're not entirely sure what parts of the face these fish are recognizing, but when I had to start wearing a face mask in the lab, they didn't recognize me as well. And it took them a little while to realize, oh yes, this is still the same person. So we should spit at her because she's the one who gives us food.
Fascinating. Wow. Robin, please, with a follow-up.
Dagmar, that was great. I really enjoyed that. And I wondered how important it was, or when you started thinking about ideas of human exceptionalism and the fact that finding these connections in nature, realising that this idea that we are elevated beyond the earth, actually realising all of these different connections, to me seems quite an important thing. When did you start realising that actually the brains of animals and living things are so remarkable, and what lessons we can learn from that?
So I think I started to get a bit of an idea when I did my undergraduate degree in biology, but it wasn't really until I started doing this PhD research, because I wanted to do it. My project looked specifically at imitation and social learning in these fish, and especially imitation is a skill that for a long time we thought only humans could do. And then we started accepting, maybe chimpanzees can do it too. And now there's more and more evidence that birds and even fish can do it as well. So I really wanted to do this research because I wanted to show that, you know, these animals which we don't really give as much consideration can be just as intelligent as us. And it was especially when I found out there's quite a lot of research that's been done on archerfish that shows that the way they look at things is exactly the same as the way humans look at things. So when the fish search for their prey, like up in the trees above them, the insect will kind of pop out when they spot it. And that's the same thing that happens when we search for something in like a, you know, Where's Waldo book. When we see Waldo, he pops out. And we remember where we've searched already, and these fish do the exact same thing, which is just really impressive because their brains are so small and they have so few neurons. And we rely on our neocortex for all of this, and that's quite a relatively new development in our evolution. But these other creatures that don't have that have clearly been capable of doing these things as well for who knows how long.
Yes, brilliant. Thank you.
Excellent. Jaideep, let's do one last final quick question and answer, please.
Sure. Dagmar, that was fascinating. And I don't think I've ever asked a scientist this question. How many times have you been spat at? And will you be using it as a metric of success alongside your citation counts?
So to answer the second part first, yes, absolutely. The problem is I'm not keeping track because a lot of the times when they spit at me, I'm so upset because they like to aim for my eyes. Which, you know, these fish, they do have quite a bit of force. They can spit up to 2 meters away, and they know just how hard they have to hit something to knock it off, you know, wherever it's standing. Obviously, I think they might be trying to take my eyes out because I don't feed them fast enough. But no, I will have to start keeping track because I think my H-index is going to be at, over the moon very soon.
Wonderful, thank you.
I think you could almost have like an archerfish competition, see whose aim is the best. The Archerfish Games. Thank you so much. That was brilliant. Okay, on then to our third finalist. I'm loving this map that comes up as well every time I introduce the next finalist. Makes me feel like a weather presenter, or you know, it's a bit Eurovision. It's like, okay, let's journey on over now to the next destination. And that's with Emma. Emma is a PhD student at the University of Cambridge. Emma works in the Department of Earth Sciences, and she gets to fabricate and study radioactive materials. She also loves growing vegetables. I just hope the two don't cross over. Or maybe that would help. Who knows? Maybe she'll tell us. 3 minutes to impress the judges whenever you're ready, Emma.
Uranium dioxide is incredible. It might just seem like a normal uranium atom that happens to be bonded to 2 oxygen atoms, but like Jack, it has loads of special abilities, and these are my top 3 most incredible superpowers that uranium dioxide has. Number 1 is incredible durability. Nuclear fuel is made of uranium dioxide, and if anyone has ever tried to explain to you how nuclear power works, they almost definitely showed you this, and tried to make out that uranium dioxide is super melodramatic, that it just falls to pieces at the slightest nudge of a tiny neutron. And technically that is correct. This is how nuclear fission works. But I'm telling you, uranium dioxide is incredibly durable and it can handle a lot. After 4 years in a nuclear reactor, a very high pressure work environment, bombarded by neutron after neutron, you might be surprised to hear that uranium dioxide stays intact, and only 3% of the uranium will have undergone fission. After fission, the fragments left behind are extremely radioactive, and what makes uranium truly incredible is that it can hold on to these fragments, it can incorporate it in its structure, and prevent radioactive release to people and the environment. Number 2, incredible energy density. The amount of energy released in fission is huge. For example, a piece of uranium dioxide this size can produce the same amount of electricity as 2 suitcases full of coal. My research looks at what happens to nuclear fuel after it's been in a reactor when it becomes nuclear waste. Number 3, incredible transformations. I know, again with the melodrama. But let's be honest, we've all been there. You're a bit hungry and you become a bit grr. But for uranium, it's less about how much food you have and more about how many electrons you have, and less about hungry anger and more about how easily it is dissolved. Both forms are useful, but in nuclear waste management, we make sure uranium always has enough electrons so it can keep it together and hold on to that radioactive material. So, uranium dioxide is incredibly durable, incredibly energy dense, has amazing transformation abilities, but we cannot forget the incredible sidekick plutonium. When we add plutonium to our nuclear fuel, we can produce even more energy. And my research looks at how that affects this transformation and the durability of our nuclear fuel waste. Now, I must go. The city needs me.
Emma, that was hilarious. Come back. Brilliant. Also, I love The Incredibles, and that scene with Jack Jack fighting the raccoon is just like one of the best ever. Thank you so much. Let's go straight to the judges' questions. Robin, let's start with you, please.
Well done, Emma. That was great. It was a lot of risks as well. It's a high risk to have not one but two sweets during a presentation, which I thought was very impressive. I was interested to know how much you were drawn to doing this presentation because of what you've seen as perhaps misunderstandings about different ideas of radioactive material, whether that was the inspiration initially, was finding out from perhaps friends or people you bumped into that this was knowledge that needed to be out there.
Yeah, exactly. Like that was the key message I was trying to get across, was that, I don't know, people think of radioactive materials as being like really like volatile, or like as if it might spontaneously just be really dangerous. But actually, like uranium dioxide is very stable, and minerals have been deposited like 1.3 billion years ago, and it's still there. So it is very steady. That was what I was trying to get across.
Also, I like to see that you are like all superheroes. When you're not using your superpowers, you're wearing glasses as a disguise. So that's very impressive.
Jaideep next for the next question, please.
Thanks, Emma. That was awesome. Jack Jack is super popular around our household as well, so I'm easily drawn into your presentation. Emma, what, according to you, is the ideal outcome when we're dealing with nuclear waste? Is it safe storage? Is it alternate uses? Or both?
Yeah, so actually, I used to work at Sellafield, where we used to reprocess fuel, so recycle it, so only 3% is used in the reactor. So if you can take out the 97% and reuse it, then that's really useful. But at Sellafield, it kind of shows like the process is you take out the useful stuff, and then the things left behind are like very radioactive. So then you have to build this into a glass, and it's just sort of all these stages that actually make it more dangerous. And in the end, we sort of decided it's safer just to take it straight out of the reactor. It's still usually intact, and then that's quite a safe way of just storing the waste, disposing of the waste. So geological disposal, where you put it in and then you seal it up so that no one can ever go in again and take it out.
Great, thank you.
Thanks. Becky, then, with the third question.
I am also a huge fan of Jack Jack, so massively appreciated this. I think as many times as we can cross pop culture with science, we should. So I'm really intrigued as when you were sort of planning this presentation, like who did you have in mind for your audience to sort of draw them in with this sort of pop culture reference?
Yeah, so I already had the costume, and then I sort of planned the whole thing around the costume. But then I realised that actually, the three forms of, the main, he has like 10 or 20 abilities, but the three main ones actually fitted really nicely with, especially like I usually focus on this transformation in my research. So I thought that was a good link. And so I know it's more for adults, but like lots of adults like children's things. Well, I do anyway. So.
Great.
Thank you so much. That was brilliant. And yeah, if you can communicate for a kid, that's actually one of the hardest kind of levels to actually communicate at, and then build up from there. So thank you so much. Next up, it's Hugo. Hugo is a PhD student at the University of Manchester. Hugo studies the spread of infectious diseases, so especially in close contact environments. So as you can expect, the past year has been pretty busy for Hugo. In his spare time, he actually writes plays, which is amazing, and he also plays many, many board games. So Hugo, I think you and I need a little side chat later, because I've been getting into board games. For now, though, I'm going to turn over a 3-minute egg timer, roll the dice, and it's over to you, Hugo, for 3 minutes. The floor is yours.
In September 2019, I started my PhD studying the spread of infectious diseases in close contact environments. At the time, I thought I wasn't going to have access to enough data. I am so sorry. My name's Hugo, and one of the things I've been looking at recently is the rate of infections in hospital, which has become super important. I want you to imagine a hypothetical, theoretical world that's been hit by a global pandemic from an exceedingly infectious virus called Verona. Okay, so when people come to hospital, we don't want them to catch the Verona virus whilst they're there, but more importantly, if that does happen, we want to know about it so that we can stop it from happening again. But there's a problem. You see, it can take anywhere from 2 to 8 days for someone who has Verona to develop its hallmark symptoms, which of course is falling in love with a member of a rival family. So, say some Juliet, 5 days into their admission, suddenly starts questioning, "Wherefore art thou, Romeo?" Based on the time from admission to developing symptoms, you've got about a 50% chance they were infected before they came into hospital, and a 50% chance they've been infected during their admission, and no way of knowing which one it is. It's the toss of a coin. Fortunately, we can work out this probability for any time from admission to simpering soliloquy, which, whilst not useful for the individual Juliet, is really important when thought of collectively. I want you now to imagine that we have 100 Juliets, and for each one we know the probability that they've been infected in hospital. If I wanted to estimate the total number that have been infected in hospital, all I need to do is add all those probabilities together. It's a bit like if I tossed a coin 100 times and asked you to guess how many times will it land on heads. You'd probably halve 100 and say 50, which is a really good guess. But what you've actually done is you've realised that the probability of landing on heads is 0.5, and you've added 0.5 together 100 times to get to 50. I do the exact same thing with the probability of being infected in hospital. And with a little bit of mathematical jiggery-pokery, the possibility for questions we can answer just opens up. What's the probability that at least one person was infected on a particular ward or at a particular time? And by knowing where and when these infections are occurring, what can we do to prevent outbreaks of similar Shakespeare diseases like TB or not TB? But then again, this is all hypothetical, theoretical stuff for a hypothetical, theoretical world. Maybe one day my work will have a practical application in our world, but I, for one, hope not. I've been Hugo. Thank you for listening.
Thank you, Hugo. Thanks so much for the star-crossed lovers spin on that. I'm going to go straight to the judges, and first judge is Jaideep.
Thanks, Greg, and thanks, Hugo. Goodness, when we heard that you were going to speak to us about infectious disease, I was wondering whether you were going to kind of skim around the big Rona, but you went head on. That was great. And of course, I've read so many grant applications that begin with the lack of data on so-and-so. I'm not sure we can have that too much. Hugo, what is something new you've learned in the past year on non-pharma interventions, so behavioral interventions?
So I think one of the things that, and FameLab in particular, on sort of science communication, needs to be a priority when it comes to these, because I think the thing that we've learned most, and I think that we can talk to a lot of people, the difficulty with trying to tell someone to change their life, to change how they're going to act, to change who they're going to speak to, who they're going to hug, who they're going to lick. It's been a real struggle, and it continues to be a real struggle. And trying to communicate that actually your changes might not benefit you. It might even not benefit the person that you're avoiding, but it might benefit someone else down the line and someone else down the line, and trying to demonstrate that chain of cause and effect when an average person probably isn't going to be affected by corona as much as they are going to be affected by staying indoors, socially distancing, not seeing those they love. That level of communication and getting that message across has plainly been difficult and needs to be a priority.
Thanks.
Thank you very much. Becky, please.
Thank you. I was so intrigued as to why specifically you're focusing on spread in hospitals, and whether the models that you have can also be applied to outside hospitals as well, and whether we can do anything fancy with machine learning and data science to do sort of predictive sort of guesses of where these next hotspots are going to occur necessarily.
So hospitals actually provide a fairly unique system, in as much as when a patient is admitted to hospital, they're in hospital. They're not going outside, they're not going to the shops, they're not going for walks or anything, they're in hospital. Therefore, when we track a patient's movement, i.e. them being transferred from one ward to another, we can be confident that they've only gone from there to there to there. There's a bit of a weakness then if you start thinking, well, could we apply this to a work environment where people do tend to move around? Maybe they'll go out for lunch. Maybe they've got a meeting in another office. These sort of things that aren't necessarily tracked and things that we're not aware of make it more difficult. So hospitals provide this unique opportunity. Another place that you could look at is prisons, and it is a place that we look at as well, for similar reasons, due to restrictive movement and knowing who's coming in and who's coming out and when.
Thank you. Robin, just a quick last question and answer. Squeeze it in.
Yeah, Hugo, well done. I just wondered, as someone who's writing plays and also obviously, wanted to get scientific ideas across, what do you think has been the most important thing you've learned so far about how art and science can work together?
I think that honestly, art and as you say, my sort of love for sort of theatre and things like that provide an opportunity to talk about more scientific, more complicated stuff, but also to demonstrate that a lot of what we're talking about, a lot of the things that we're doing, are things that everyone could understand. Maybe not the fine minutiae, and being able to establish what the fine minutiae is and what is the stuff that people could understand and get on board with and get involved with. Art and theatre and plays really provide that opportunity to be able to communicate that with people.
Thank you so much, Hugo. All right, then, we are halfway through tonight's finalists. Crikey. Remember that not only will our judges crown the FameLab UK 2021 runner-up and, of course, champion, you will get to crown your audience favourite. So do keep a note of who you're particularly enjoying, who's giving the most engaging, the most exciting, understandable talk. Whatever quality really you decide you want to judge us on. This is your audience favourite. We're going to open the vote for the audience favourite after all the finalists have performed. Now, though, it's over to Rebecca. A PhD student at the University of Glasgow, Rebecca works in the Materials and Condensed Matter Physics group, and when she's not studying the mirror coatings of gravitational wave detectors, she's perfecting a mirror glaze on a cake. Thank you very much. I just wanted to show that I enjoy Bake Off. Rebecca, 3 minutes on the clock. Over to you when you're ready.
This is one of the most famous paintings in the world. What if I told you the only way to save this painting was to destroy it? Okay, not destroy, I'm being a tiny bit dramatic, but we might have to damage it. Paintings age, they fade and crack and flake, and if you saw the sunflowers fresh off the easel, you'd be amazed at how much more vibrant it was. The yellow paints that Van Gogh and his contemporaries used weren't very stable, and they tended towards browning. But wait, this is supposed to be a science talk, right? Why am I talking about paint? Turns out the way we're going to save these paintings is using science, specifically something called spectroscopy. Now, I want you to imagine that someone is shining a torch at a wall, and in between the torch and the wall is a piece of glass. You can't see the glass, but you'd probably still be able to tell me something about it. Like, was it red? Or blue? Spectroscopy works a little bit like that. We shine something at our sample and look at what comes out the other side. There's lots of different kinds of spectroscopy, but I want to tell you about two of them, and they're often used in tandem because they give us slightly different information. The first type is my speciality, and it's called EELS. It shoots electrons through your sample, and when they come out the other side, some of them will have lost energy. The amount of energy they lose is characteristic of what elements they've interacted with. So, for example, if you see a bunch of your electrons have lost 543 electron volts, then you know that there's oxygen in your paint. The second type I'm interested in is EXAS. It works almost exactly the same as eels, but it uses X-rays instead. And I'm sure you're all familiar with X-rays as a way to look inside things. But there's a problem. Eels and EXAS can sometimes damage your sample, and you wouldn't want to burn a hole in a Van Gogh. Instead, tiny flakes of paint are scraped from the surface of the painting, so small you would never even notice them gone. So I was being dramatic even when I said we might have to damage the paintings. Investigating the paint flakes using EXAS, it was discovered that the element chromium, which was responsible for the vibrant yellow of the paint, was less common at the surface, and that paints containing more sulfur were more prone to browning. But what actually causes that browning? Well, using eels and EXAS and artificially aged paints, it was discovered that the culprit was light. The energy of the light the paintings are being exposed to over time is what caused the chemical reaction that darkens the paint. And so researchers were able to recommend that in the future, the paintings only be exposed to certain wavelengths of light, helping to prevent further browning. Art and science are often pitted against each other, and physicists painted as Philistines with no interest in beautiful things. But I love art, and I hope this speech has shown you that the two aren't diametrically opposed, and that science does have a place in art, helping to preserve paintings for generations to come. Thank you very much.
Rebecca, thank you so much. Like you, I've got a huge passion for art, especially paintings, and I love that you brought the two together, showed us how to preserve it. So thank you for that. Let's go to the judges then for the questions, and I'm going to start with Becky, please.
Great. Thank you, Rebecca. I thought that was great. I love that you took such a niche technique and put it into context of something that people would understand. I was wondering if you could maybe talk through some of the other applications that this might have that the wider public might also appreciate as well, or even just something they might never have thought of that this could be used for. Again, because it is quite a sort of a niche technique.
This I don't currently work on preserving paintings. I actually work on the coatings used in gravitational wave detectors, which is not something I think the general public would be that interested in. But one of the other things I'm applying this technique to is the cladding used in nuclear reactors, and ensuring that we understand the structure of the cladding in nuclear reactors and how it can change being, when the nuclear reaction is going on. And that can help improve the safety, and I think that's something that the general public could definitely understand why that is important. But we use that technique there as well, so it is a very, widely applicable.
Mm-hmm. Thanks.
Cool, thank you. Robin now, please.
I wondered, and it was great, by the way. I love that mixture of art and science there, and in particular, as Greg said, painting. What was? Did you go through any debates about what painting you really want to choose? Because it's such a hard thing, isn't it, to work out what's the one that's going to lure in the most people? Did you have a little list? Did you kind of go through a checklist of the possibilities of which painting?
Well, I knew I wanted to pick an Impressionist painting because that's the art that I'm most interested in. I also really like Degas, but I thought the sunflowers was one that is very widely, even if you're not super interested in art, I think a lot of people have seen the sunflowers or at least are aware of it, so I wanted to pick one that people would definitely sort of recognize.
Brilliant, thank you.
Awesome. We've got a live chat going on our Zoom call, and I loved the number of people who are like, great pronunciation of Van Gogh, which I've probably just done incorrectly. Jaideep, final question to you, please.
Rebecca, incidentally, one of my favorite painters is Jackson Pollock, and I like the sort of chaos in the colors that he chooses as well. Is there a science behind why certain colors appeal to us, or why we sometimes tend to link colors to emotion?
I'm sure there is. I'm a material scientist, so that's not really my purview. But I know this technique, or sort of understanding the different pigments used and how they might have changed since artists first used them. I was talking about it from a conservation perspective, but there's also lots of research on making sure that you sort of understand what it originally looked like, because the pigments that different artists used, they chose them very deliberately. Like you said, Pollock deliberately chose his paintings. He didn't just pick up whatever he had in his studio. So it can sort of inform art historians if you can understand exactly what they looked like when they were just finished.
Very interesting. Thanks, Rebecca.
Brilliant. Well, thank you so much, Rebecca. Really enjoyed that. I've also just been told in the chat, no, mine was not a good pronunciation. So fair enough. Right, just a final trio of finalists left then this evening, starting off with Sama, who is currently studying for a Master's in Astrophysics at Cardiff University. Sama wants to share her love of maths with us all. So you've got 180 seconds on the clock, starting when you do.
Staring up at the night sky. It's gorgeous, isn't it? I mean, just look at it. Galaxies, supernova, stars dying and being born and all that crazy stuff. It seems vast and like it'll go on forever, doesn't it? Well, what if I told you that that could not be further from the truth? Let's take a look, small, at our own Milky Way. It has around 100 to 400 billion galaxies with new ones being formed each year. Well, if we just tapped and asked ourselves, well, gosh, how many stars are even born each year? You'd be super surprised to know that it's only 3. Only 3 new stars are born each year. That means star formation is slowing down. In fact, 95% of all stars that will ever exist in our universe have already been born. If that's not daunting enough, trust me, there is more. The Milky Way, along with Andromeda and like 50 smaller galaxies whose names sound like phone numbers, form our like local group, a galactic neighborhood, if you will. 100 of these local groups all around us form a supercluster, and then obviously there's many more of those. 2 trillion galaxies in the observable universe alone. If we're traveling at the speed of light, we can only reach like 6% of those. 6%. That means there's some sort of horizon. Something like a horizon, right? Like something we cannot cross, something beyond which nothing can reach us. It's called the cosmic horizon. Everything beyond that point is traveling relative to us at a speed faster than that of light, that we cannot communicate with it. It's lost to us forever. And as the universe expands more, faster and faster and faster, more things are dissipating beyond that horizon. 7.2 million stars since I started talking alone. And yes, years down the line, far, far, far in the future, beings living here on our local cluster that is gravitationally bound will have no idea of the rest of the universe. They will have no idea of the Big Bang or the cosmic microwave background. To them, it is just them in the universe. The universe is dark, infinite, static, with nothing else in it but themselves. And I'm not telling you this to scare you. On the contrary, I'm telling you this because you're alive right now, in a time that is optimum for research, in a time of the universe that is fantastic. So go out there, do your science, do your research, explore, and don't you dare look back. Thank you so much.
Yes, Sama, you got us all fired up. Loved it. Okay, let's get straight to Robin for the first question.
I love that talk. It's something that really fascinates me. One of the big problems, I think, with sometimes talking about these ideas is, as you mentioned a little bit there, that kind of existential anxiety. And does that ever worry you, that when people get a sense of the enormity, like to try and even put 200 billion or 400 billion in your head becomes just many and loads. So how do you feel in terms of dealing with the images you hope are inside people's heads?
You see, to me, it kind of relaxes me and excites me how fleeting we all are. It's so small. So I want everyone to sort of be like, look, listen, like, we all know we're going to die one day. We're not going to live a billion years. You're not going to see all those things later on in life. You're alive now. It's wonderful. You exist, and it's amazing. And things have existed before you, billions of years, and things will exist after you. But it's so wonderful that you're alive right now. Don't think that you're just nothing. It's actually the absolute opposite. Think to these grand, huge things as a reason that you exist. It's just wonderful. Do your science, do your research. It doesn't have to be science. Do your art, do your music, do whatever makes you happy, because it's your time, basically.
Brilliant, thank you.
What an answer. All right, straight to Jaideep.
Thanks, Sama. That was wonderful. I wish I had your superpower of just switching off the television by doing that when the kids are watching too much of it. Sama, what is the biggest step change in astrophysics or astronomy that you want to see in your career as a scientist?
I would really like to see LISA go up to space. It's the space detector for the gravitational waves that is planning on being, is it released, is it 2030 is meant to go up? And I would really, really like to see that, because I would like to work on that. I'm working on gravitational waves, that's my area of research, and I would really be like love to be one of those people who sort of dismembers all of the data because when it goes up, there's going to be a lot of data coming in, and we're not really sure how to unfurl all of these threads that are coming in and detect what caused what wave. So I'd love to be able to see that, hey, scientists have now reached a time in life where we can look at a ton of data coming in and we can see, oh hey, that came from 2 black holes, oh hey, that came from 2 neutron stars. I think it'd be revolutionary, for me anyway, just because I find it super interesting.
Wonderful, thank you.
Thank you.
Yeah, that is going to be a lot of data. Crikey. All right, Becky, straight to you. I know this is very much in your wheelhouse.
I know, I feel like I found my soulmate in Sama. I'm just like, oh, my kindred spirit. I was wondering, Sama, you'll know this, there's so much misinformation around our science, astronomy, astrophysics, everywhere on the internet. How do you, with your science communication efforts, like combat that kind of level of not just misunderstanding, but also like false information that's out there, fake news, fake science kind of thing that's out there?
First of all, huge fan. You were like one of my big inspos to do this master's. But like, okay, so misinformation is a huge thing. There's a lot of people are like, flat earthers and stuff like that. I don't want to diss anyone, but we don't want to go there. But like, I feel like with that, something like what you do is where I would like to see myself in the future. I'm like, I want to start small and just educate people around me. Like if I hear someone saying something wrong, I'd be like, oh, actually, how about we don't do that? How about we like do the right thing? And then I wanted to go out more and more. I'd love to be like a lecturer later on in the future, and I'll have students and then I'll have people asking me, and I'll go to conferences and stuff, so I'll be able to communicate with them more. I just think it'd be wonderful to have resources that are out there, such as on YouTube or journals or whatever it is, articles that are accurate that we also can reference to. So I don't just want to stop with like lecturing and videos and stuff. I also really like to write things that are scientifically correct with references to actual papers, not just news articles or whatever. I think being scientifically correct and reaching as much audience, even if you're starting small, is the best way to do it.
Yeah, it absolutely is. Thank you so much, Sama. Moving on then. Our penultimate finalist is Katie, an engineer at the UK Atomic Energy Authority. Katie is working on building a fusion power plant, and she tells me that she enjoys applying her experimental physics background to her cooking, apparently with varying degrees of success. So 3 minutes to see what you kick up, Katie, starting when you do.
Hello there. Glad I made it. Time travel's a little bit difficult. I'm Katie. I'm from the not too distant future, and I'm here to tell you about some very cool technology. Of course, I'm from the future. You're probably wondering, do we all space travel? But your real question should be how. Your current space technologies are all well and good for short journeys to and from the ISS, but they're not so good at long distance, as they can't go fast enough or far enough. And so, to get outside our solar system and to the stars beyond, you're going to need some better tech. And the answer is in our sun, quite literally. Nuclear fusion is the process that powers our sun, and not just our sun, but every star in the known universe uses this reaction to burn hydrogen in a colossal ball of heat and light. It's enabled not just solar systems to evolve, but life on Earth as well. Fusion works by giving 2 small atoms enough energy that you can smush them together and they fuse. And in doing so, they form a larger atom, and they release some energy. It's Einstein's E = mc² in action for you. And this technology has actually been experimented in this time with the aim of putting electricity on the grid. And if you can crack fusion on Earth, it's a small step for man, but a bigger step for mankind to put it on a spaceship. Here's how. Chemical propulsion rockets, how most rockets work today, work by burning their fuel into a hot gas, and then by throwing that hot gas out the back. If you throw it out fast enough, you push the rocket forward in the other direction. Take this balloon, which is filled with air. If I let the balloon go, The air coming out the back pushes the balloon forward. And the speed that this stuff is leaving the rocket determines its exhaust velocity, which gives the rocket's efficiency, like its miles per gallon. And a fusion rocket would work using this principle. But instead of burning cow farts, it would use one of the most energy efficient reactions known to physics to achieve an exhaust velocity of around 20 times greater, meaning it can go faster and further. And this would solve a lot of the issues with current space tech. It took a chemical rocket 9.5 years to reach Pluto, and it had no fuel left over. But a fusion rocket could do it in 4, and with fuel left to stop. Better yet, a fusion rocket's fuel would be hydrogen, which exists in space, and helium-3, which, whilst incredibly rare on Earth, is actually abundant in asteroids, which would enable travel outside our solar system. I've really got to go, but I thought I'd get you all dreaming about how we can reach the stars in a spaceship powered by stars.
Great, Katie, come on back. Are you warm in that?
A little bit.
Fantastic. Okay, straight to our first question then, and that's Jaideep, please.
Thanks, Katie. That was really awesome, and I'm sure you get loads of street cred calling yourself a rocket scientist. That was awesome. Tell me, actually this is a two-part question, so it's a bit of a cheat on my part. What do you hope to find if you were to get to Pluto, and what would you bring back? Because obviously with fission you could come back.
You could come back. I mean, from a purely just my own point of view, I just want a rock or something, just to be like, I've been there. But I think from a more scientific point of view, it would be to find something new and to kind of, to enable science to develop and progress, and just to allow us to say, yeah, we've done that. That's really cool, because it's a stepping stone. Once you can do one thing, you can do another, and you can do another, and then your options become limitless, and that's a very cool thing.
Cool.
Brilliant, thank you. Becky.
Thank you. I love your energy. Seriously, that was great. I'm really intrigued as to why you chose this method of propulsion. Why did you choose fusion? Because there's so many other ones out there that people are talking about. Like, why this one?
So, yeah, as you said, there are many, many hypothetical space travel options. The reason I went for fusion is, one, my own work is based around fusion, but fusion on Earth, so putting energy on the grid. And yeah, I guess it's an extrapolation from that, of dreaming of a future where if you can do it on the grid, where else can you put it? What else can you do with it? And also that I think it's kind of widely considered that fusion propulsion is possibly the most realistic form of space travel, that's the one that's actually going to get us far. There's lots of amazing sci-fi based ones, but I think they are just that, whereas fusion is one that's might sound a little bit sci-fi based, but it has a lot of roots in a reality we can deliver. So
cool. Robin, with the final question, please.
Thank you for that. That's great. I love hearing about space exploration. But the big question that often comes up, and we've seen it a lot during the helicopter on Mars, etc., is why are we going into space when we have so many problems on Earth? So when someone says that to you, and I'm sure they do, what's your first comeback?
I think, well, as a scientist, from a curiosity point of view, but I think from a people point of view as well, like humans are innately curious. It's our curiosity and our desire to learn more that has enabled us to evolve and develop to the point we are today. And I think that part of that is going beyond and discovering the new things. For way back when it was like getting on ships and sailing and finding new continents and finding new places. And I think we've got to a point now that to do that, it's hopping on a spaceship and going a bit further, and who knows what we'll find.
Brilliant, thank you.
Awesome, great question, great answer. All right, well, yes, we'll leave you. Thank you very much. Enjoy the adventure. Bring us back a Pluto rock. All right, so our final finalist then is master's student Madeleine from the University of Glasgow. Madeleine told me that when she's not reading academic papers and looking at GWAS data, hope I said that right, she's experimenting with new recipes in her very tiny kitchen. So many of our finalists are into cooking. Unsurprising this last year. But Madeleine also says she has a goal to read 365 books this year, which is phenomenal. If you could just take your head out of that book actually for a second. Yeah, great. Okay, it's your turn. I'm joking, obviously. That's an amazing goal. So, Madeleine, over to you for our final 3-minute presentation, which will kick off when you start. Thanks.
When you're a child, adults constantly ask you, what do you want to be when you grow up? And for me, the answer was as clear as a sunny day in spring. Indiana Jones. I yearned to go on adventures and uncover mysteries and puzzles and wear that cool hat all at the same time. And I sit before you today and confidently say, mission accomplished. Well, kind of. I go on adventures constantly, but the map I follow isn't one that Indiana may have been familiar with. My map is the genome. And we typically define that as the complete set of genes or genetic material within an organism. But it isn't as simple as following a single road from point A to B or finding a temple in the jungle. No, it's more of a labyrinth with twists and turns and connections that we explorers haven't completely figured out yet. And to make things more fun, we can't just look at one single map, because despite our overwhelming similarities that we share as humans, we have to look at many genomes in order to make a discovery. One way we try to uncover the mysteries hidden in the human genome are the use of genome-wide association studies, or GWAS for short. GWAS gives us direction. It allows us to look at the vast terrain of multiple genomes simultaneously. So instead of looking immediately for X marks the spot, we look at the entire map to see where we want to go first. Like many of my fellow researchers, my current quest is venturing into uncharted territory. My current interest lies in the genetic influence on mental and physical health in a region of the genome that's known for its role in our immune response. Previous studies have shown that people with mental illness have an increased risk for cardiometabolic disease. So think of something like obesity. And it's been shown that both obesity and mental health have a strong role within our immune response. So knowing this, I'm able to use GWAS in order to investigate whether the same parts of this region affect both mental and physical health. And I'm excited at the possibilities of what I might find. Because even identifying a small part within the genome that is significant can help contribute to the bigger picture. Whether it might fill in the space for someone else's research or is important all on its own, it has the potential for later down the line to help with things like risk assessment, treatment, and prevention. And so I'm not fighting foes or looking for treasure, but the adventures I'm on hold great purpose. And as for that hat that I mentioned, well, it turns out I don't look very good in fedoras, so I guess I'll just leave that to Indy. Thank you.
Thank you so much, Madeleine. Hey, with the hat, you do you. I love the Indiana twist, though, and the adventure. Thanks so much. Okay, right, straight to Becky, please.
Thank you, Madeleine. I really enjoyed that. I had a wonderful narrative to it. I'm probably going to ask it's probably a bit of a mean question, to be honest, but this kind of science comes with a whole host of just ethics dumped on top of it as well. How do you respond when people say that this question whether we as humans should even be doing this kind of research and this kind of science? Like, should we have that power, you know?
That is an amazing question, because it's true. There are a lot of things that go into this that it's important for scientists who do study genetics that we take into account, you know, the sociological aspects of it. And I think that the only way to answer this question is how much are we willing to look for the knowledge that can help better our everyday life, but just, you know, help us understand humans a little bit better too. Because genetics and genomics doesn't only allow for us to look at disease and things like that. It also helps us look for things like personality traits, how much you might sleep even. There are so many things that come together in this weave, this almost map, if you will, that just make it more useful for us in everyday life and for the long run.
Great question, Becky, and great answer, Madeleine. Okay, over there now to Robin, please, for the second question.
Yes, that was a great presentation. I just wondered, in terms of, there's so much misinformation about genetics. There's so much stuff that makes it into the press, which is based on very little. When you were deciding what your subject was going to be, why did you narrow it down to this in particular?
Well, a couple reasons. For me, I think a lot of people hear those words like genome and genetics, and they have this idea in their head that it's either a mad scientist trying to manipulate it to make superhumans, or it's to do with food, which I understand both. You know, I'm a lover of movies, so I get it. But for me, I think when I think of genetics and genomics, I truly think of the adventure. I truly think of the knowledge that we don't have yet, that is right there. We just haven't looked at it the right way or asked the right questions. And I think it's a relatable thing to be able to do, is to look at something that's excitable, like an adventure, like the things that, you know, the people that we look up to, you know, did in the movies when we were young, or anything like that. And so this, for me, gives it just more of an attainability, and also gives it for something that anybody can find an interest in, because it's just looking for that next adventure.
Brilliant, thank you.
Thanks. And Jaideep then, with our final question.
Madeline, that was great. I love the way you sort of connected to everyday issues and everyday sort of challenges that we face, and you could have the answers to. I'm really intrigued by what a day in the lab looks like for you. What do you do when you get in? How do you go about your science?
So I was hoping that no one would ask this question, but I guess the cat is out of the bag, because my day looks a lot like me sitting at a computer with multiple monitors, and I look at data, and I look at people's published work, and then sometimes I look at catalogs. Every now and then I get to look at actual genomic data, which is a lot less easy on the eyes, if you will. But quite frankly, I just sit in a chair most days, and I can do it from my home. So I'm having adventures in my home office with a cup of tea.
Great, so we can associate.
Yeah, I think a lot of people can empathise with that. Becky was nodding along.
Yeah, you're like, I'm an astrophysicist. What do you do all day? Sit at a desk.
Well, that is how a lot of science is done, right? So thank you very much, Madeleine. There you go. You have now seen all 8 of our UK finalists perform, which means now it's time for the judges to go away into their own little digital room and battle it out between themselves until they settle on a decision of who is going to take the runner-up spot and who is going to be crowned the FameLab UK 2021 champion. But don't you go anywhere. Don't you go anywhere, because if you joined us after my rather long admin-packed introduction, then well played. But you will have missed the message that we are actually recording this a couple of weeks before Cheltenham Science Festival. So what you're watching is a pre-record, not live. But that's great, because it means I can now do this and jump forwards in time. When the judges have made their decisions, welcome to the future. The judges are back. Our finalists are back. But before we hear who wins, let's find out who is your winner. It is time for you to cast your vote for the audience favourite. And the voting is now open. You're going to be asked, this is all explained on the SurveyMonkey, but you're going to be asked to choose your top 3 finalists, okay, and rank them with, unsurprisingly, your favourite as number 1. To help you decide who deserves your vote, we're going to play you a recap video. Full instructions as well are going to be on the screen throughout, so you know where to go to vote. And then we're going to be back with that very special video looking back at FameLab history. Let's check out the recap.
And then they pass it through a tube called a pilus, injecting it in to a neighbouring cell. Basically, it's bacterial sex.
Archerfish can also take faces that they've learned in 2D and recognize them even when those faces are rotated up to 90 degrees.
But in nuclear waste management, you make sure uranium always has enough electrons so it can keep it together and hold on to that radioactive material.
All I need to do is add all those probabilities together. It's a bit like if I tossed a coin 100 times and asked you to guess how many times will it land on heads.
Tiny flakes of paint are scraped from the surface of the painting, so small you would never even notice them gone. So I was being dramatic even when I said we might have to damage the painting.
If we're traveling at the speed of light, we can only reach like 6% of those. 6%. That means there's some sort of horizon.
Ah, hello there. Glad I made it. Time travel's a little bit difficult. I'm Katie. I'm from the not too distant future. I'm here to tell you about some very cool technology.
No, it's more of a labyrinth with twists and turns and connections that we explorers haven't completely figured out yet.
So there you go, what are you waiting for? Get voting. Now this is the final year of FameLab in its current format. It began 17 years ago at Cheltenham Science Festival when SciComm was really just in its infancy, and it's had the most incredible impact. It's influenced many thousands of scientists and engineers in their careers. So we thought, let's have a little video. We've pulled something together to celebrate this amazing achievement. And while it's on, please do keep voting. Here it is.
Of all the different things I've helped to create, FameLab is the one that I'm proudest of.
I'm going to be honest, I was sceptical about whether it would work.
One of the things we wanted to achieve with the Cheltenham Science Festival was a wake-up call to the whole science communication field. There were too many turgid events going on in grubby university lecture theatres, and we wanted to show that you could put on really professional, exciting, fantastic events, really ones that would just make the audience hum. And we wanted to show the whole field that you could do things with quality.
I was judging the London Heat and it was amazing. People were literally queuing outside the Science Museum to take part. So it really was like a TV talent show. And the whole thing had such a magic about it. And there were so many people that you thought, these people definitely need a public space to talk about science or engineering or maths or whatever it was they were doing.
I wanted to take part in FameLab just because I guess I've always loved science, I've always loved talking about science, and it's just a really great opportunity to try and distill an idea down into this incredibly short period of time. It wasn't a format I'd tried before. Squeezing a complicated topic down into 3 minutes. I think I probably wrote about 3 or 4 times as many talks as I actually delivered.
The FameLab process has given me the confidence to go and do science communication in other spheres. When I get opportunities to talk to live audiences or on the radio or on television, on podcasts, I'm no longer scared of that as a daunting prospect and I don't know what to do. FameLab taught me skills and gave me confidence in science communication such that I now embrace those opportunities.
And FameLab just sort of, it's like Moses, it parted the Red Sea, and it sort of just organized all my thoughts into this one narrow stream in the middle and gave me a direction to actually go forward with what I want to do in my YouTube channel.
FameLab really gave me the opportunity to build my confidence and be a champion of science communication, and to really inspire a culture change to encourage others to be part of that as well.
But to boil it down to a couple of minutes is a real art, and it takes a lot of rehearsal to get it that precise. And in a sense, it changed how I lecture as well. I became less sort of routine in my lectures. I was less sort of more willing to sort of improvise on what I was talking about, and a bit freer in what I did, a bit more spontaneous, because I think it gave me confidence.
Being able to talk clearly and explain yourself concisely is just it's such an important skill for any scientist, even if they're talking to specialists, that basic set of skills still comes into it.
I think the FameLab has had a profound impact on the course of my career since taking a part. I've gone on to take up a professorship in science communication. I've now written 5 books in popular science. And so the most important thing for me for FameLab wasn't just the taking part in the competition, but it was all the people that I met along the way, people that I've collaborated with and worked with in outreach events for the years since I took part.
The main impact for me was meeting all these people at the Cheltenham Science Festival. I didn't know that there was this community of people that cared about outreach, that cared about communicating STEM. I got into doing shows with Andreas Seller. I met Matt Parker there, and we're longtime collaborators now, along with Helen Arney. So off the back of meeting them, I started doing Festival of the Spoken Nerd. It's a comedy show about science and maths. Just knowing that there was this support of other people that are doing this stuff.
Now we've coaxed people out of the lab with a trail of Smarties to the FameLab stage. I don't think they're going back in. I think they realised that being out, sharing their work with the public is valued and valuable and a lot of fun.
Well, there you go. What a legacy FameLab is. It's wonderful to see what participants have got up to since their FameLab experience, and this is clearly just the beginning for our 8 finalists tonight, isn't it? You've got a few more seconds to get your audience vote in. In fact, finalists, will you count down with me? Let's go from 10. 10, 9,
8,
7,
6, 5,
4,
3,
2,
1.
And that's it. Right, that is the audience vote closed. We will be revealing who has been crowned the audience favourite very, very soon. Now though, judges, it's over to you. Such a brilliant final. I don't know how you're going to make a decision out of this, but as is tradition, let's announce the runner-up first. Becky, I'm going to ask you first, before we do that, just to tell us your thoughts in general about all of our finalists tonight.
Yeah, we were, all of the judges, incredibly impressed with every single one of you, especially the fact that you've all adapted so well to your new stage, right, which is a Zoom box, essentially. You all use the frames so well, sort of exiting and everything, the frame, and we really did enjoy seeing that you didn't turn it into a hindrance, you actually made something of it. Also, so many good props today as well, that was great to see. Also, the humour in today's presentations was great. I mean, who knew scientists were funny, right? I think we've all learned that we're all very funny today. The other thing we want to say is that it's so great to see your enthusiasm, the fact that you all have this level, not just for your own research, but for science in general and for science communication as a whole. And I think we all said, all the judges, we said every single one of you, we can see you going ahead with and just doing great things with science communication as well. So that was so lovely to see. Before we announce the runner-up and the winner, I just want to remind you all that that's not the be-all and end-all. Not winning today does not mean that you're not a good science communicator. You all are fantastic science communicators. I did FameLab, made it to the national final, and I didn't win. And I do science communication still. Everything's still going well for me. So, don't be downhearted if it isn't you. We did deliberate for a very long time, as Greg said. It really wasn't an easy decision for us. And so I just hope you've all had fun today as well, and that you've learned something in the process, and that the audience have enjoyed it too. And you've enjoyed voting for your favourite, because I did win the audience vote. So maybe that is the most important, and you shouldn't just listen to us judges.
Just a subtle drop of that one. Love it. Okay, all right. So now it's time to reveal the runner-up. And the runner-up is going to be announced by Jaideep.
Right, okay. So as Becky was saying, the first impressions are so important when telling a story, and you all did a fantastic job just drawing us straight in from the very get-go. It was something that all the judges really picked up on and really drew us into your presentations. The runner-up, who we have selected, stood out for her framing of her research, both head-on and in profile. She also made the science really jump out at us, or shall I say spit out at us, and really hit us in the eye and sort of drench our faces in the science. And I'm sure you've sort of figured it out, but the runner-up who we've selected is Dagmar and her archer fish. So congratulations, Dagmar.
Where are you? Unmute yourself. How do you feel being the runner-up of FameLab UK 2021 in an incredibly strong final?
I'm a bit shocked. I'm very happy. I'm definitely going to go, when I go to the lab later, and I'll tell the fish about it. I'm sure they'll spit at me in congratulations or annoyance that I'm late feeding them again. No, I'm really, really happy. I'm just really glad I got to share some of my passion for these fish and, you know, tell people that, you know, fish are really smarter than we think. We should probably treat them a bit better than we do.
Brilliant. Well, we really enjoyed your talk. You're going to get £1,000 to put towards something SciCommie. Any ideas yet what you'd like to put that towards?
I've actually have an idea for a YouTube channel, something I want to call the Smart Fish series, which actually discusses fish intelligence and, you know, does a bit more of this comparing humans and fish performance or fish and other animals. And I have a friend who studies fossils, and we want to go fossil hunting for fossil fish together here in Fife. So it could definitely help with those things.
Amazing. Okay, great. Well, that sounds brilliant. Please let us know when those videos are live, because we will all want to see them. Thank you so much. I love that your celebration is not just, you know, a bit of money and starting the channel, but also one in the eye from an archer fish. So who else is going to get that as a prize? Congratulations. Thanks, Dagmar.
Thank you.
Now, before Robin reveals who is the FameLab 2021 UK champion, I think it's time to find out who your audience favourite is. Now, as this is pre-recorded, I'm past Greg, not present Greg, which means I can't reveal the result of the vote. So present Greg and the FameLab team are going to be in the live chat right now as you're watching this, and they're going to type the winner into the audience vote. No, they're going to type the audience vote winner into the chat. It makes sense in my brain. So we're also going to post it on the Cheltenham Festival's social as well, so you can go and have a look at there. So please, future Greg and team, reveal right now who is the audience favourite. It's in the chat. Congratulations to whoever you are. Let's see the pre-recorded celebration of the finalist. Seamless. Okay, well, congratulations to you. Now we're back in the past. So this means we now just need to crown the FameLab UK 2021 champion. And Robin, you've got the privilege of announcing who this is.
Yeah, I have to admit, I'm a little bit disappointed by Dagmar, because I was hoping she was going to turn out to be one of those evil scientists that would go, I'm going straight back to the lab to eat all of the archer fish. I need them no more. But it turns out she's one of those benevolent scientists that there seem to be so many of now. It was, I think, as others have said, it's one of the most important things is that all of you continue to do science communication. We have so much great science communication out there. We need more and more, because even though science communication is getting better and increasing, at the same time anti-science, pseudoscience stuff that is going against, as we've seen during the pandemic and in other occasions as well. That's why you need to keep doing all of these things. Every single person left us with an idea as we replayed each presentation. It was magnificent, and there were certain people, I think, who just, we managed to be able to replay almost everything, and there were images and there were ideas. And so I don't want to play around with it and give you hints of who it is, because then someone, is that me? Is that? I'm just going to say the winner is Rebecca, who so brilliantly combined art and science, and that was done by other people as well. I'd like to make that very clear. There was lots of great combination of visual imagery, of ideas, of philosophy. So everyone was magnificent. Rebecca, yours was the one that we just felt just pipped ahead of everyone else, just because we had so many images left in our heads. So congratulations.
I'm in shock. Sorry, everyone's was so good. I'm so surprised. Yeah, thank you.
How have you found this this whole experience then of being part of FameLab?
Oh, it's been so good. It's been, you know, we talked a lot about how we're not in person, but we've still managed to make friends and been chatting and stuff. And it's been really good hearing everyone else's research, and it's been so much fun. I'm really glad that I did it. Yeah.
That's one thing we love being part of FameLab. It's the community as well. Like a lot of the finalists, that friendship kind of really lasts, and then the other cohorts, the other years of FameLab kind of all come together. So it's lovely to see. So you're going to receive £2,000 to go towards your science communication wants and desires, and you're going to represent the UK in the FameLab International Final later this year. How does that feel?
I'm sorry, I'm speechless. I'm so excited, sorry.
Awesome. That's lovely to see. What do you think's next? What's next for you? Like either in research or I guess now with science communication, of course, as well.
Honestly, I hadn't really put much thought into what I would do with the prize money if I won it. I'd sort of forgotten that we would get any, if any, you know. So I guess this is a chance for me to actually put a bit more effort into science communication and make it something, maybe steal that Dagmar's idea and make a YouTube channel or something. Next for me is just plodding along with my research and finally being allowed back into the lab soon, which is quite exciting because obviously we haven't been allowed in, so start to actually get more time on the microscope, which I'm really looking forward to.
Awesome. Well, enjoy that. Enjoy your new crown of being the UK FameLab 2021 champion. And I think what we should do is we should all have a little pyrotechnic celebration for you. So if everyone can reach for their party poppers, I've lashed 4 together because I always kind of like doing that. We're going to pull the party poppers. Here we go. This is not just to Rebecca for being the champion, Dagmar for being the runner-up, the audience winner, who we don't know who that is, but well done to you, but also to everybody. This is for all the finalists. Incredible evening of talks. Ready? 3, 2, 1. Woo! All of you finalists will get to go to Cheltenham Science Festival 2022 for the whole week. You're going to get a whole schedule of events to network. You're going to make contacts, you're going to improve your psychom skills further. We can't wait to see what you get up to. Before we say a goodbye, just some quick thank yous. Thank you to our judges. Thank you, Dr. Becky Smethurst.
You're very welcome. I had so much fun. Thank you for having me.
Thank you, Dr. Jaideep Gupta.
Thanks, Greg. Thanks, everyone. Awesome being here.
And thank you very much, Robin Ince.
Oh, do you want me to say something? I just gave a wave.
Okay, thanks. You were in the other screen, so I couldn't see you. I was like, is he still here? Is he checked out?
I'm going to see, because one of the things that I loved with Katie had that really annoying thing I noticed when you let the balloon go and you went, it's not doing it properly. So let's... That's what it was meant to do, wasn't it? So I really felt for you at that moment. I was like, oh, that is so annoying when you go, that's never happened before. Why has the balloon just gone, no, thank you? Stage fright.
The beauty of live is the beauty of live performance and talks. Thank you very much to the whole FameLab team, led by the ever brilliant and wonderful Elspeth Kenny. Also to Wendy Sadler and to David Price at Science Made Simple for the masterclasses, to Ben and Kofi and the whole team at Still Moving Media, to Dale and Mel for helping us with the pre-records and the edits. Thanks to the whole team putting on this fantastic hybrid Cheltenham Science Festival this year. Do check it out. There's lots of in-person events in Cheltenham, but there are loads of online events available as well. And if I may, I'm going to do a little plug for How to Save the World, the series of events where I'm getting to chat to a whole range of experts about green energy and sustainable cities and clean water and much, much more. My name is Greg Foot. It's been an absolute pleasure being part of this yet again. Thank you for joining me in my spare room tonight. See you again soon, I'm sure. Goodbye.